Hey guys, this is MacBerry. I'm just doing my presentation for Advanced Security Lab 4. So the first part of this lab was to create a private and a public key, which for this task I used PuTTY. As we could see at the start, I had no keys, and then I started creating the key, and I use the parameter of the RSA. Then I have my two keys, a public and a private key. I hold on to the private key for myself, so I'm a private, and the public key is if you want to send an email, which is in task B, I have to send an email to our lecturer Anil, which I will attach this to it, just he will be able to encrypt or decrypt my email. And we already know what is the public and private key. So the private key in private key for encryption and decryption, we use the same key. The private key is semantic because the only key is copy or shared by another party, basically. And the public key is two keys are used in one key for encryption and another decryption, basically. And then for the part B, we're supposed to download and install a version of XML, which the first version in Terra Inc. I wouldn't be able to download it. There was something wrong with the link, so I went with the second one, the Postbox, which was really handy to use. Install it, set it up, and then I had to import my own keys into it. Or you could have basically inside them you had that option. It would create a key for you, a public key for you. And then the part C of my, or the part B is the part B, but like the second part of it was send an email to our lecturer Anil, and we have to make sure public key is attached to the email, so he will be able to decrypt our emails. And yeah, so we could see from the second part of the part B is I started just a quick test for myself before I send the actual email to Anil. So I just composed an email, just create a new email, and I just typed this text to it. This is the test, and then I had to make sure it's encrypted. And over here, I can attach to my public key as just attachment, so you could show if I send an email with a text or an attachment, it will encrypt the both of them basically. So attach my keys to it, as we could see down there is attached, and I send my email to myself. So you could see over on the right hand side on the corner, there's no text. You cannot see a text, or it's basically encrypted. Nobody else can see it unless it's like they have the public key and they could decrypt the email. And the attachments again, which are over here, you could see my public key, but around the other side, you cannot see it says no name. But you could see another attachment, which is that's the public key, which the receiver could start to decrypt my email to understand what my text is and what is my attachment. Then for the part C was just a research and talking about the kind of attacks. So basically the network time protocol and precision time protocol. There's four attacks, and the first attack can be mounted against the system is the NTP, and the second one is a reply attack, and the third one I found is a rogue master attack, and the fourth one is basically the packet interruption and removal, another form of attack. It was straightforward. It's nice to know the attacks. For example, the NTP is which type of uses a DOS attack basically, and then the reply attacks occurs when the attacker requests protocol pockets and repays them without the amendment. Uh, yeah, and then for the last part was to implementing the RSA encryption. So I started with understanding how does the encryption work first. So the sender will send the plain text, and then we use the public to encrypt the text. Then we have a ciphertext basically, and then we need that private key to basically decrypt that ciphertext, and then the receiver will understand what is that text. Um, it is really explained well in the report, which is with the code example as well. So basically, RSA is the first option we have to do, the first task we have to do is choose two prime numbers, then we calculate the modulus of it, then we calculate the totation, and then often write it as a phi basically, and then we choose a number which is a core prime to the other number, and we find a GCD of it, and then we calculate the private key. Um, yeah, that's all for me. Thanks for listening.